Okay, so I've made a start here. I've put just a couple of coils on, and it's a bit slow. Let's pull that a bit tighter. It's a little bit slow, so I'm going to get my wife to crank that over and count the amount of turns while I keep tension on this, and I can keep it pressed on with my thumb, keep it nice and neat. Keeping it neat, it doesn't matter if it's neat or not. But if you don't keep it neat and nice and tight, you'll not be able to get enough turns on it. It'll end up here, and you'll not be able to get the coil in. So you have to be able to get 400 turns on, and it not be any prouder than here. That's it. It's going to be it in the flywheel. So it has to be neat because it keeps it nice and tight then. All right. So we'll see how we go on now. There we are. It's got 400 turns on it. That. And I think it's just about right. It's not proud of the wires. Cranky my finger. The wires here are not proud of the insulators, and are not proud of the arcs there, because that's where the flywheel runs. So you don't want to come up to here, else the flywheel will start rubbing on the coils, and I've got to put some insulation on it yet. So it's not as tight as I like it, but doing it by hand, it's not bad that. Okay, that's the coil with some insulation tape wrapped around it. That'll hold it nice and firm. All I've got to do now is connect the two wires up to these two supplies, and what you've got is an AC supply coming off there. So those two will go across my rectifier, and then the other two wires that come off the rectifier, which is positive and negative, will be my DC. So crank some wires onto this, flap it onto the bike, and see what we've got. Right, this is the coil in position, and this is wire coming off one side. The other wire comes out the back down there. And I've brought them under this way and out the front, so the flywheel surface here doesn't rub on anything here. Now, to say I'm annoyed is an understatement, because these two wires that come out here, this copper wire I've wound it with, it's not copper. It doesn't solder. I cleaned the ends off, and I was going to solder the wires direct on, or put a soldering connection on, and it won't take solder. I think it's aluminium wire. I've come across it before. This won't take solder. I've cleaned all this varnish off, tried it loads of times, and it will not take solder. So what I've had to do is crimp a connection on and then solder my wire to the crimp. It's a little bit bulky there, you see it sticking out, and I wanted to avoid that, but I'm annoyed because it doesn't say copper on the spool, and I assumed it was copper. So there you go, you assume things and it's not right. So what you've got here now, this is the all lighting coil, rewired, 400 turns. I'm going to put the flywheel on and then see what's coming out the other end. Okay, I've got the flywheel on, although you cannot be able to see it down there, but there's a keyway. This flywheel fits on a taper, and there's a keyway as well, which is get in front of the camera, is this. So I'm going to put the keyway in there, knock it into position, and then put the nut on, tighten it up. Now, I don't normally use a torque wrench, but in this case I am doing, because this has to be tight, and it's 55 foot-pounds. So for a nut of like this, it's quite tight. That it's just on the point of them and stripping it off. So either being a taper, it needs to be the right torque setting. So I'm going to use a torque wrench. Now this keyway that fits in here, fits in there. This keyway is not to hold the rotational forces of this flywheel. It's there to position the flywheel in the correct position to the crankshaft. It doesn't take any strain laterally. The taper holds it, not the key. The key is only there to get the timing in the right position. Right, I'm tightening the flywheel up. I've got my torque wrench on there. It's set to 55 foot-pounds, and the method I use is I put a G-clamp on the flywheel, and then where the leg of the G-clamp comes down there, this bar is jamming it there so that this can't rotate, and then I can tighten the flywheel up. I find these G-clamps are really good for clamping the flywheels. You don't have to tighten them up, all you have to do is be nipped up, and when you try and turn it, it actually tries to turn it and jams. Doesn't damage the flywheel. Used it loads of times. So I'm now tightening it up at 55 foot-pounds, and then I'll run it and then try it again, because it's important that this is tight, because if it slips you can wreck the taper. It'll shear the woodruff key and wreck the taper, so it is important that this is correct settings. So I don't normally use a torque wrench. So what we've done here now, we've connected an ammeter up across the positive and negative on the solid state rectifier, disconnected the voltmeter. Okay, so we've got a dead short across the coil. Let's see what we're pulling. Just about 2 amps. Now that's almost on tick over. I would expect it to, when it's running, it'll be a lot faster, so I'll get a few more amps. But 2 amps at that speed at 7 volts, I'm quite happy with that. I'm sure I'll be able to cope with that. So that seems like it's successful. What I need to do now is get it running and see what happens when I get to full revs.